Hi everyone. In this video, I will explain how to determine a transfer function of this basic electrical circuit. This circuit has two resistors R1 and R2 and two inductors L1 and L2. The input function or the excitation function is theta I and the output function is theta naught. For the transfer function, we can write Hs is the transfer function is equal to theta naught over theta I. These values are in S domain. As the first step, we have to convert this circuit into in S domain. These are the impedance value in time domain. This is impedance value of R1. This is impedance value of L2. This is impedance value of L1. And this is the impedance value of R2 in time domain. As the first step, I convert this circuit into the S domain. There are two inductors and two resistors. This is R2, this one R1. This is the excitation function. In S domain, impedance value of inductor, we can write it as SL. Then for L1, we can write SL1 and this is SL2. And this value are theta. This value is theta naught. And now I will write voltage at that point is V1 and voltage at that point is V2. And I mark the current values. Current flowing through this R1 is marked as I1. This is marked as I2. This one I3. This value I4. Then we can apply KCL, Kirchhoff current law, to this V1 node and V2 node. First, I will apply at the V1 point. According to the KCL, at the one node, total incoming current I equal to total outgoing current. For V1 point, incoming current is I1 and outgoing current are I2 and I3. Then I1 is equal to I2 plus I3. Then we can write the equation for I1, I2 and I3 based on the voltage value and impedance value. For the I1, we can write theta I minus V1 over R1 is equal to I2 V1 minus V2 over SL2. This is the impedance value of the inductor 2. Plus, here the voltage value is 0. Then I3 value V1 minus 0 over SL3. SL1. That is the impedance value of inductor 1. Then I will simplify the equation. Theta I over R1 minus V1 minus V1 over R1 is equal to V1 over SL2 minus V2 over SL2 plus V1 over SL1. Theta I over R1 plus V2 is SL2. This V2 value is equal to theta naught. This is equal to V1 1 over R1 plus 1 over SL2 plus 1 over SL1. This is my first equation. Then I can apply the KCL to the V2 point. For that point, the incoming current is I2 and outgoing current is I4. Then I can write I2 is equal to I4. For the I2, this is the value. V1 minus V2 is over SL2 and it is equal to I4. I4 is the current flowing through the R2. We can write V2 minus 0 over R2. From that one, V1 over SL2 is equal to V2 over SL2 plus V2 over R2. For this one, V2 is equal to theta naught. Then V1 over SL2 is equal to theta naught 1 over SL2 1 over SL2 plus 1 over R2. From that equation, we can get the V1 value. Theta naught 1 plus SL2 over R2. This is the second equation. And from 1 and 2, we can obtain the transfer function. In here, we know the value of V1, theta naught 1 plus SL2 over R2. And from the first equation, V1 is unknown term and we know the V2 is equal to theta naught. Then we can apply the V1 value to here. Then I will write the equation theta I over R1 plus theta naught SL2 is equal to V1 value is theta naught 1 plus SL2 over R2 times 1 over R1 plus 1 over SL2 1 over SL2 plus 1 over SL1. Then theta I over R1 is equal to theta naught times 1 plus SL2 over R2 times 1 over R1 plus 1 over SL2 plus 1 over SL1 minus 1 over SL2. This is the equation. From this equation, we can get a relationship between theta naught over theta I. This is our transfer function. Hs is equal to theta naught over theta I. For that one, you have to simplify this equation. And final answer will be SL1 R2 s to the power 2 L1 L2 plus this times L1 R2 plus R1 L2 plus R1 L1 plus R1 R2. This is the final equation, and numerator has s to the power 1, and the maximum polynomial of the denominator is s to the power 2. And this is how the determining of transfer function of this simple electrical circuit. I hope you will understand this process.